Example 1. Can you determine if the triangles are similar? If yes, write a triangle similarity statement. Now, depending on the information we're given, that will dictate which similarity test to apply. So for instance, in this example, we're given all three sides on each of the triangles. So if we take a look back at our tests, the side is the one that appeals the most because this one requires the usage of lengths. So that's what we're going to use for this example. First, we need to make sure that both triangles are facing in the same direction, and I'm going to do that by flipping this triangle, WXY. And I'm going to make use of the lengths in order to dictate the direction in which I'm going to flip or rotate. So here I notice that 13 is the longest side, so I'm going to write longest here. And then I notice that 8 is the smallest. So I'm gonna write smallest, and then 10 is the one in the middle. So in order to make sure that this triangle is facing in the same direction as this one, I'm gonna make sure that I have the middle side right here, the smallest side right here, and the longest side right here. So here 69 is the longest, 40 is the smallest, and 50 is the one in the middle. So now I can put 50 right here, 69 right here, and 40 right here. Next, I'm going to use this right angle, and this right angle tells me that the name of it is X, so I know this one's X, and then X and W make that 50, so this one has to be W, and then the last one's going to be Y. Okay, so now that I've made sure that both triangles are on the same direction or facing the same direction, I'm actually going to make some space and get rid of this triangle here. And I'm attempting to do the SSS postulate. So I gotta check that, or I have to verify if all of the corresponding sides are proportional. So I'm going to begin with 10. So BC corresponds to XW, so I'm going to do 10 over 50. So let's write this down. BC corresponds to XW. BC is 10, and XW is 50, and 10 over 50 is 1/5, and this equals 0.2. Let's do the next one. So here we have BA, and BA corresponds to XY. So I'm going to get BA and then divide that by XY. BA has a value of 8, XY has a value of 40, and 8 over 40 is also 1/5, so we get 0.2 again. Now I gotta check the last side, so that would be AC. AC corresponds to YW. So here, let me just number these ones. So then 3 is going to be AC over YW, and AC has a value of 13, and YW has a value of 69. Now since 13 is a prime number, I know it's not going to have a common factor with 69. So here, let's input this into a calculator and see what we get. So hopefully we get 0.2. If we do not, then these triangles are not similar. So here I'm getting an approximation, rounding to the nearest tenth, to the nearest hundredth. I'm going to get 0.18. Now here we have to realize that 0.2 is the same thing as 0.20, right? 0.02 and it's not the same thing as 0.2. So think about this as being 20 cents, and here we're having 18 cents. So we can clearly see that here the triangles are not similar because the corresponding sides were not proportional. This last one does not match with these two. So here we would write the triangles are not similar. Okay, let's check out another example. Example 2. Now here, now in this example, we're given two sides. So two sides and one angle for each triangle. So here we're also given two sides and one angle. In this scenario, it will not be wise to use side, side, side because we're not given the third side. We're given two sides, one angle, so then this is screaming at us, telling us to use side, angle, side. So here, you have to make sure that these two lengths that correspond with these two lengths are proportional, and we have to make sure that the angle in the middle, those angles are congruent. So let's go ahead and make sure that our triangles are facing in the same direction, and I'm going to do that by changing one of them. Here I'm going to rotate triangle QPR. So if I rotate this one, so now perfect, they're facing in the same direction. There we go. And now we can see that angle R corresponds to angle U, angle P corresponds with angle X, angle Q corresponds with angle W, and side length QR corresponds to length WU. So let's go ahead and begin with the angles. We can immediately see that the angles are congruent. This angle R has one tick mark, this angle U has one tick mark, so corresponding angles are congruent. Let's go ahead and record that. We get that angle R is congruent to angle U. Now we have to verify that the corresponding lengths are proportional. So let's get UW, and we're going to divide that by RQ. So UW has a length of 108 and RQ has a length of 24. And 108 divided by 24 gives us 4.5. Now let's do the same thing with the other length. So here we have UX. We're going to divide that by RP. So here we get UX over RP. UX is also 108. RP is 24. And we already did this calculation is 4.5. Corresponding lengths are proportional and the angle in between is congruent, so we can claim that these triangles are similar. Here we're going to get triangle, and I'm going to choose a direction, so I'm going to begin with RPQ. Triangle RPQ is similar to triangle, we got to mimic the pattern, triangle UXW. Triangle UXW by the SAS postulate. So we also have to be explicit about which postulate we used when claiming that two triangles are similar. And of course, I mean, your work should also be displayed. Let's check out one final example. Example 3. To do this problem, we have to notice that we have vertical angles here. And remember that vertical angles are always congruent. So these two angles are congruent. Now we can clearly see that for this problem, we're going to want to use the angle-angle similarity postulate. So it was disguised, but we were able to notice that here we had a angle that was not explicitly given to us. So we have two angles, and now we want to see if these two triangles are similar. So let's go ahead and make sure that this part is facing in the same direction as this part. And to move this triangle around, I'm basically using the angles in order to guide me in overlapping them. So this angle has to overlap with this one, and this one has to overlap with that one, which is this figure right here. And the red one is a V, the yellow one is U, so the last one has to be W. So let's go ahead and record that. So we have V, U, and W. So let's go ahead and kind of delete this part right here. So this part became this, and now this one is super easy because the angle similarity postulate says that as long as you have two corresponding angles that are congruent, the third one has to be the same as well. So here V is congruent to R, U is congruent to U, therefore we meet the criteria for the angle-angle similarity postulate. If two angles of a triangle are congruent to two angles of another triangle, then the two triangles are similar. So we're done. Let's go ahead and record it though. So we have angle R is congruent to angle V, and then angle U is congruent to itself. Therefore, we can claim that triangle VWU is similar to triangle RSU, and this is by the AA postulate. So go ahead and try the examples, and after that, well, I'll see you on the next lesson.